Hello students, and this is the start of lesson 18 practice problems. Again, remember, if you need to do these by yourself first and then come and watch the video to make sure that you get the correct answers and maybe get a little bit better explanation of how this needs to be done. So with that, we're going to start on lesson 18 practice problems. It's on page 293 in your workbooks. So we're going to start here on number 1. Since Tyler goes to the store, his budget is $125. Which inequality represents X, the amount of dollars that Tyler can spend at the store? Well, obviously he has $125. His budget's $125. He doesn't want to spend any more. So we're looking at numbers that are going to satisfy this, which are less than. Now, can it equal the endpoint? Can it equal 125? Well, if he has a budget of 125, it sounds like he can actually be spending exactly $125. So, though he'll probably spend less, he will obviously go and spend up to and including possibly $125. All right. So we look at this. X is less than or equal to 125. That looks pretty good. All right, because that's the numbers which are less than 125. So that one looks pretty good. X is greater than 125? No. All right. His budget's $125. He doesn't have any more than that. He can't spend more than 125. All right. This one, same thing. He's great. He's spending with this one, he's spending at least $125 on up. So that one's wrong. This one says he's spending less than 125. So yeah, that's probably most likely what's going to happen. He'll spend just slightly under $125. But he can spend all the way up to 125, including everything. So he can spend 125 even. All right. So that's what this budget of 125. So I'll go with letter A, but this is a pretty close second. All right. Close second. And it's probably closer to reality. But that's the constraint we're going to go with. Letter A. Number 2. Jada is making lemonade for a get-together with her friends. She expects a total of 5 to 8 people to be there, including herself. She plans to prepare 2 cups of lemonade for each person. Okay, so let's kind of like, before we get too far, let's see what we got here. She expects between 5 and 8 people. All right, so we got a 5, we got an N for the number of people, and we got an 8. So I'm thinking it's going to be this. So the number of people can be greater than or equal to 5, but the number of people has to be less than or equal to 8. All right. So that one is what I think she's going to get out of this top one. 5 to 8 people. So it says down here, select all math students that represent the quantities and constraints. I'll definitely say, is it A? Well, this needs to be less than or equal to. So for that one, I'm not going to choose A just because these little symbols here are a little bit jacked up. All right, I want them to include the number 5 and the number 8. So I'm thinking that B here is a good answer. Okay. Now that you have the number of people that we're dealing with, she plans on making 2 cups of lemonade for each person. All right. So if she took the number that she has here and multiplied it by 2, that would be the number of cups that she would have. All right. So she plans to prepare 2 cups of lemonade for each person. All right. Now, is she going to make exactly that? Well, that's what she'll plan on doing. She'll make exactly 2. It doesn't say that she expects a range of how much cups of lemonade they're going to have, but we know she's going to make 2 cups for each person. So I'm thinking that this one is also the number of cups lemonade is equal to 2 times the number of people showing up. All right. So I'm going to say that C is also pretty good too. So I'll say that the cups equals 2 times the number. Okay. The lemonade recipe calls for 4 scoops of lemonade for each quart of water. Each quart is equivalent to 4 cups. Yikes. Okay, so let's see what this is. 4 scoops of powder for each quart. So that's kind of like 4 scoops per quart. And 1 quart is let's see, for each quart of water, 1 quart is 4 cups. So what we got here, so let's see, so you have 4 scoops and 4 cups. So that sounds like, if you cancel out the 4s, there's 1 scoop for every 1 cup. All right, 1 scoop of powder for every cup of ultimately lemonade. All right. Is there anything that we have here? Well, L, it is the number of scoops of lemonade powder. So the scoops of lemonade and the cups of the cups of lemonade and the scoops of lemonade. All right. So scoops equals cups. All right. We just kind of figured that out. 1 scoop for every 1 cup. So I'll say that one's true as well. Okay. And let's see. She gets together and she says, so the number of cups I need. Well, let's see. I got 5 and I got 8. So that means if I have, for every person, I needed 2 cups. All right. So 8 times 2 is 16. And 5 times 2 is 10. So again, if she's less than or equal to up here, I'm thinking we should go and choose less than or equal down here at the very bottom for the number of cups you have here. So I'm going to go and select Foxtrot as well. And I don't think this one is going to work out because it should be less than or equal to. Okay? Greater than or equal to. That kind of stuff going on. Equal to. All right? So I'm thinking Bravo, Charlie, Delta, and Foxtrot all sound like plausible ways to get this thing done right the first time. All right. And on to our next one, number 3. All right, number 3. A doctor sees between 7 to 12 patients each day. On Mondays and Tuesdays, the appointment times are 15 minutes. Okay? On Wednesdays and Thursdays, they are 30 minutes. On Friday, they are 1 hour long. The doctor works no more than 8 hours per day. Here are some of the inequalities that represent the situation. All right, so if you look at this, there's a quarter hour and there's a 1 hour. So there's your 15 minutes and the 1 hour. So Y would be the, what does each variable represent here? It looks like Y is going to be appointment time lengths. So I'll go appointment time lengths. All right. Can it be less than or equal to? Well, we can schedule them for 15 minutes. You might take a little bit longer on some days, but not on others. But that sounds like the appointment time lengths. All right. And then you've got an X. Let's see what the X says. All right. Let's see. You've got 7 to 12 patients. So X sounds like the number of patients per day. Per day. All right. So there's your 7 to 12 right there. And then X times Y has to be less than or equal to 8. So you got a little 8 there. So it sounds like that's the number. Since Y is the appointment time lengths and X is the patients per day, it has to be less than 8 hours a day. All right. So what they're saying there in this one is the amount of time that you spend with the patients has to be less than 8 hours. So you have basically the number of patients times the length of time each one is, and that gives you the total hours. So this is total hours he's going to be spending working with patients. Why does the expression XY in the last equation mean in this situation? It's total hours. Total hours with patients. All right. X is going to be the appointment time length. Y is the number of patients per day. Let's see. And so, let's see, 17 patients each day. Okay. Number 4. Han wants to build a doghouse. He makes a list of materials needed. At least 60 square feet of plywood for the surfaces. I'm going to guess that's the sides and the roof. Maybe the bottom. at least 36 feet of wood planks for the frame of the dog house, and between 1 and 2 quarts of paint to make it look pretty for the dog. All right. His budget $65. Plywood costs this amount per square wood. Planks cost this amount, and paint costs this amount. Right there. Okay. Writing quality should express material constraints. Okay. So we'll say that the budget has to be less than or equal to $65. Let's see. We know that the cost of plywood, all right, so the plywood is 60 square feet, right? So 60 square feet times 0.7, that's dollars per square foot. There's your plywood. We add to that the planks of wood, but I need 36 feet of wood planks, so 36 planks and 0.10 per foot, plus 1 to 2 quarts of paint. Alright, so at most we have 1 to 2 quarts of paint, so we can have, let's just go 2 quarts of paint at $8 a paint, and that has to equal your budget. Alright, well now this one right here says between 1 and 2. So if it's 1.5, you still got to get 2. So we can make a kind of a constraint here. 1 is less than or equal to Q, which is less than or equal to 2. That's the quarts of paint right there. All right. You'll notice that the B here and the B here are the same. So we can also say that 60 times 0.7 plus 36 times 0.10 plus 2 times 8 has to be less than or equal to $65. That's another way of saying the exact same, since the two B's on this one are the same. Let's see. I'm thinking that that's about all we got. And of course, we'll just say, we'll throw this one down here as well. 4 quarts of paint. Okay, then that should work. Okay. And that's all the ones I can think of on that one. On to number 5. So now we got a few little review questions to worry about. The equation V equals 1/3 pi r squared h represents the volume of a cone, where r is the radius and h is the height. Which equation is solved for the height? So it has to be h equals something, all right? So let's just go through this. V equals 1/3 pi r squared h. And I got to solve for a height, all right? So we have to go and basically tear this thing apart here. Since this is multiplying by 1/3, we can divide by 1/3 or multiply both sides by 3. And let me go and get out my other pen here real quick so you can kind of see what's going on. If I multiply both sides by 3, then the 1/3 and the 3 cancel. I'm multiplying by pi, so if I divide by pi, then I'll get the pi's to go away. And I'm multiplying by r squared, so if I divide by r squared and divide by r squared, the r squareds go away, and now I just have height all by myself. So we're looking for something that looks like this. So I'll say no to that one, and it's still got a 1/3 there. I'll say no to that one. And I don't know where they got the subtract sign in, so that's completely jacked up. 3v right there times pi r squared right there. So that looks like the correct answer right there. And that's the basis of how to do this. When you're solving for an unknown, you figure out what's going on here. Here it says 1/3, so it's multiply by 1, divide by 3. So how you undo divide by 3? Well, you multiply by 3. Here it says multiply that times pi. Well, you undo it by divide by pi to both sides of the equation. Multiply by r squared, so we divide by r squared, both sides. And then once we do all those, I just have h left over, and so now I know what h is equal to, right there in red. Number 6, solve each system of equations without graphing. All right. So as you know, there's like 2 big methods that we use to solve these. One is elimination, the other is substitution. Now on this one, I would say it's probably going to be, elimination is going to be a little bit easier. But you could certainly use substitution if you wish to. I'm just going to go through with just the one method. So on this one, draw my little line, and I'm going to subtract. Why? Because if you look at this, you got a 2 and a 2, a 3 and a 4. The 2's here line up. All right. If I subtract the bottom one, the x's will go away, and my life becomes easy. So 2 minus 2 is nothing. 3 minus 4 is a negative 1y. And 5 minus 9 is a negative 4. So now y equals 4. Well, if y is 4, we can just substitute it back in here. 2 times x plus 3 times the 4 equals 5. Well, that's 2x plus 12 equals 5. 2x equals 5 minus 12, which equals a negative 7. So, divide both sides by 2, x equals a negative 7 halves, right there. All right, so now you have the two numbers that you need to work with. So let's see what happens here. We'll check our work. 2 times a negative 7 halves, all right, there's your x, plus 4y, so plus 4 times 4. Well, that has to equal 9. So let's make sure it does that. Well, you see you have 2 times a 7 divided by a 2, so the 2's here cancel. So I just get a negative 7. All right, 4 times 4 is a 16, equals 9, question mark. Well, negative 7 plus 16, that is in fact a 9. So, yep, it's correct. All right, so your answer here will be a negative 7 halves, comma, 4. Right, moving on to the next one. Next one, you've got a couple of different ways that you can do this one. Again, you could go and get rid of the least common denominator, but since they both have 2/3 right here, I'm okay with this thing being the way it is. So I'm not going to worry too much about it. I'm going to move in here a little bit. So you can see 2/3 here. So again, we can do either elimination or substitution. I like elimination. All right, so I'm going to go and draw my little line here. And I could add and get rid of the x's, and then I'd have to add fractions, though. It might be easier if we subtract again to get rid of the x's, just because nobody wants to deal with fractions. So 2/3 minus 2/3 is nothing. 1 minus a negative is going to be a plus. So 1 plus 1 is 2y. And then 7/3 minus 1. So let's see. 7/3 minus 1. That's the same as 7/3 minus 3/3, which is, let's see, that looks like it's a 4/3. Okay? Is that what we got here? 7/3 minus 1? 4/3. All right? Now I got a 2, so I got to divide by 2. Y equals 4/3 divided by 2. A 2 will cancel with the 4. So I got 2/3. Okay? So I know what y is. It's 2/3. So at this point, we can go through, now that I know what y is, right? 2/3. I can go through and I can start to solve for the x. So let's see. 2/3 x plus 2/3 equals 7/3. Yuck. I don't like fractions. Here's the little clue. Since they're all the same denominators, I can multiply everything by the least common denominator to eliminate the fractions. Whee! Let's multiply everything by 3. What happens? What's 2/3 times 3? Well, the 3's go away, and you just get a 2x. Multiply it times that one, the 3's cancel, and you just get plus 2. And you multiply this one by the 3's cancel, and you get a 7. All right? So now, I'll just subtract 2 from each side. 2x equals 7 minus 2, which equals 5. So x equals 5 halves. 5 halves. All right, and we'll check it with the bottom one here. Let's see. 2/3 times 5 halves minus 2/3, all right, so we're still right here, equals question mark 1. Okay, so this is what we got. All right, all I did was I took this and I substituted in the y and the x that I got, and I use this one to find it, so I'm going to check with this other one, make sure it works. All right, so 2/3 times the x value minus 2/3 equals 1, question mark? Well, let's look at this. The 2's will cancel, so I'll get 5/3 minus 2/3 equals question mark 1. Well, you got the same denominator here, so you can just do the math up above. So 5 minus 2 divided by 3, which is 3 divided by 3, which is 1. So yes, 1 does equal 1. So that's a good answer. Okay. Number 7. Here's a pair of x and y values that make each equation true in the system of equations. Okay? So they gave you these equations right here. Explain why the same pair of values makes this. Well, if you notice, 5 plus 4 is 9, so you got your 9x. 3 plus 7 equals 10y. And then 8 plus 34 equals 42. Well, all it happens is here, you added like terms above here to get this. So I'm just going to say added like terms. So yeah, it's true. There's not much to it. I mean, you can just like do this and do the math. And when we add these, you get that. Which ordered pair of this is a solution to this equations? We got a whole bunch of numbers here. So we could do trial and error, or we could go through and we could try to solve this thing. All right. Well, let's see. You got a bunch of numbers here. And so you got 7s and 3s and 5s and 9s. And so, yeah, you could do substitution in here. Or we could just solve this thing. So you have 7, 3, 5, and 9. You don't have a lot of things here that are going to be like, obvious what we can do. All right. So what I would like to do is I would like to see you got a 3 here and you got a 9 here. I know that I can take a 3 out of both those and make it a lot simpler. You don't have that up here. 5 and 7, they don't have a common factor I can take out of them. The 3 and the 9, they have a common factor that I can take out of those. And if you look at this, remember whenever a number adds up to 3, 6, or 9, it's divisible by 3. Well, look, 9 plus 1 is 10. 10 plus 5 is 15. 15 is a 1 and a 5. You add that and you get a 6. So since it adds up to 6, I know I can take a 3 out of that. So if I took 159 and I divide it by 3, 3 goes into 15 5 times. 3, okay, so there's your 15, carry it down, there's a 9, 3 goes into 9 3 times. Alright, so if I take a 3 out of here, I can get, I'll have my same one, 7x plus 5y equals 59. And then down here, I'm going to have an x, a minus 3y, and a 53. Right? So all I did is I just took that one here and just reduced it. I multiplied everything, or just divided everything by 3, and I can move from this form of the equation to this. It's the exact same thing. All right. Now if you look at this thing, you might be able to do a substitution. You could do about anything you want. But this thing makes it a lot simpler to go through here. All right. Now, just as I look at this thing, what I'm thinking is, I've got some number, and I got to subtract a number out of here so that I get a positive 53. All right. If I don't put a positive number, if I put a positive number here, this thing's going to be a really big negative. So I have to have a huge number out here. Okay. So in all likelihood, I have to have a positive number here and then add another positive here to get all the way up to 53. So let's think about this. All right. So let's see. How about I take this and I will solve. I'll try to eliminate the x's. I'll go and multiply the bottom one by 7, just to go and make my life a little bit easier. Again, there's more than one way to solve these things. You might have a different way of solving it, which is just fine. Now I take this bottom one and multiply by 7, I get a 7x. All right, if I multiply 7 here, I'm going to get a negative 21y. And if I make 53 times 7, let's see, 53 times a 7, that's a 1 and a 2. That's 371. 371. All right, and now we'll just go ahead and we'll just subtract. Well, 7 minus 7 is nothing. 5 minus a negative 21 is the same as 5 plus 21, which is a 26y. Okay? And 59 plus 371, let's say I got the 371 there. Let's add the 59. 9 and 1 is 10, carry the 1. 5 and 7 is 12. 13, carry the 1. And that's a 430. It equals 430. Well, how many times does 26 go into 430? I got to divide both sides by 26. Y equals, all right? You notice how it's subtracting here, right? I made a mistake here. It should be 59 minus 371, so this is wrong. I made a mistake. It is 5 minus a negative, so that is 26, but it should be 59 minus 371. Let's take our calculator here, and let's do the work, because this is probably what you'll be doing. You'll say 59 minus 371, negative 312. So that's 312, and it's a negative. All right. So 312 divided by 26. Let's see what we got here. Divided by 26. That's negative 12. Why is negative 12? So it's either this one here or it's this one here. Okay. That's out and that's out. Okay, so now let's continue on. Now I still have this equation here that I work with, so it's pretty simple. So x minus 3 times a negative 12 equals 53. So that's x minus a negative 36, which is the same as x plus 36 equals 53. All right, I got to subtract 36 from each side. X equals 17. So the only one that has a positive 17, not that one, it's going to be this one. So Charlie is my answer. Okay. Now yes, there's more than one way to solve this, and you could go through, multiply both of these together and start getting some numbers. Again, that's just one way that I would do it. Number 9. Which equation has exactly one solution in common with the equation y equals 6x minus 2. All right, so let's look at this. What kind of equation is this? All right, the answer is it's y-intercept, and the y-intercept tells you slope and the y-intercept. So the slope is equal to 6. The y-intercept is at 0, negative 2. That right there. Okay. So which equation exactly has exactly one solution in common with this one? Well, let's see. If we were to do that, if it has just one solution in common with it, then they have to intersect. If they intersect, that they have to have different slopes. So let's go through and just look at the slopes of these things. So this is a standard. The slope is negative a divided by b. Right? That's going to be a negative 18 divided by a negative 3, which is 6. Same slope. You know it's not that one. What about this one? Well, I got a 1/2 y. Let's take this thing and just multiply everything by 2. So 1/2 times 2 is just a y. 2 times 3x, well, that's a 6x. And 2 times the negative 2 is a negative 4. Same slope. That's not it. Let's look at this one. I have a 2y equals 4x. All right. So on this one, I'm going to multiply everything by a half just so I get a single y out there. So 1/2 times 2 is 1, and it's an equal. 1/2 of 4 is 2x, and 1/2 of 12 is 6. Oh, look. Slope. Slope is 2. So I'm pretty much thinking that C here is the one we should be looking at. One more to kind of go through. This one's a little bit screwy in its format, right? But we can still do it. 3, 12, and 18 all have multiples of 3 in them, right? So if I just take a 3 out of each one, or multiply it by a third, however you want to think of it, 1/3 of this is y. 1/3 of a negative 12 is a negative 4. And 1/3 of 18x is 6x. Well, look, y equals mx plus b. All right, it's the same equation as this one. The slope is 6. You know that's not right. All right, it can't possibly have only one. It can only have one if they had different slopes, so you get one intersection point. So this is the only one that you can have, just Charlie. That's the only one, because it had a different slope. The rest had the same slope, 6. On to number 10. How many solutions does the system of equations have? Explain how you know. All right, so let's look at it. First thing, let's look at the slopes. Here, the slope is a negative 4 because it's the y-intercept. Y equals mx plus b, so that negative 4 is the slope. This is a standard form, so let's look at what the slope is. It's a negative a divided by b. Okay, so it's a negative 2 divided by 8. Well, that slope then is negative 1/4. They have different slopes, therefore they must intersect once. So m1 does not equal m2. I'll put a 1 there, I'll put a 2 there. Therefore, one intersection. And then you can go on and you can start solving this thing if you want to. You can do substitution into here. And you can go and find that point. But I know that it just wants to need to know how many solutions. 1. Slope's different. Okay. Well, that's all there is for the practice problems on 18. Thank you for your attention.